Hello and welcome to my presentation. Today I will talk about a project called Temporary Relay Network, unlocking the power of the UAVs for on-demand services. My name is Mohammed Hussein and my supervisor is Dr. Khan Kalantari. First of all, let's take a look at some general ideas about our problem. When you make a phone call or use the internet, you do not connect directly to the other person. Your data first goes to a base station, like a cell tower, and then to the main network. This base station works as relay between you and your destination. Sometimes relay network cannot give you good service. For example, when you are in a remote area, the signal is weak. Even in cities or common places, when many users connect at the same time, the service quality goes down. The service provider can use temporary equipment to support the network. This can be fixed stations like a portable base unit or UAVs communication devices. In this work, we focus on the UAVs. UAVs are a very good option to support the networks. They can be deployed quickly, and because they fly at higher altitudes, they can give better communication than ground station. They can also guide coverage to more important areas. But there are challenges: where to place them, what obstacles they face, and how they should move them for the best performance. Let's have a quick look at the workflow. First, we understand the importance of the topic. Then we go through a simulation experience to see how it's work. Let's use a simple story to better understand the importance of this topic. A short story about a person named Bob. First event, an ordinary busy day, just like always. But suddenly everything is changed and earthquake happens. Natural disasters are not planned and they can happen anytime. An earthquake can cause serious damage to everything. Bob is also badly hurt and needs help. The only idea Bob has a send signal. But in these cases, all communication lines get damaged. But Bob needs important things, most importantly, information. So for now, we leave Bob alone to think about how he can solve his problems. The second event, Bob and his friends are making plans for the concerts. So Bob goes to a concert and starts having fun. But there is a problem. He had planned to meet his friends. So he takes his phone to call his friend. But the phone signal is weak and cannot do this job. The reason for this problem is not very complex. When too many people are in one place and try to use this phone, the local mobile network cannot give full service. This can happen in a stadium, festival, or any place. So again, we leave the Bob alone deal with the problem he is facing. But what if we stronger the services when it become weak? So let's go back to the first story and see what happened there. UAV network can provide fast and convenient service. You can quick tell your friends and your family how you are. You can also know about your loved one and get news and rescues information. So let's also make a happy ending for the second scenario. Here we can deploy UAV networks to make the communication stronger. Now, with a strong communication, many things become easier. We can share our moment with others or even start a live stream. Bob and his friends definitely have a good time. Will the topic of the UAV's coverage be discussed more in the future? In one paper I read, this topic was prediction. In this paper said their discussion will become more and more popular in the future. This is very good and give us hope. Now let's design a simple simulation model for this topic. First of all, we need a three-dimensional space. Next, we need some user in environments. And in urban space, there are tall buildings that act as obstacles. Apart from buildings, there are also no-fly zones such as a high-voltage power station or natural obstacle like a mountain. And of course, we also need some UAVs. Assume that the UAVs fly at a fixed height, so we need consider one flight plan for them. Therefore, we can simplify the model and consider the environment as a two-dimensional. For better compressor, we designed 5 modes. We save the position of the 20 users over 20 time step, the position of the obstacle, and the initial information of the 4 UAVs for each mode. And for the path calculation, we have a set of rules. There are some obstacles on a map that the UAVs must avoid. We call these rules fit 5. According to equations, if a UAV gets closer than safe distance, a penalty given, and if it collides, a heavy cost will be applied. We also need to define some rules for the movement of the UAVs themselves. For fit 3, at each time step, UAV can move only up to the limit distance. We also set the rule fit 4 for the training angle, because too much rotation can cause deviation and loss our control. Now let's add a few rules to keep the signal strong and stable. Fit 1 follow the idea that the farther user is from the signal source, the lower the communication quality becomes. Another important issue is the distance of obstacles, which create noise and reduce efficient communication. Obstacles such as a building can strongly affect the signal. Another important point communication is the number of the user received at least the minimum quality. And finally, the selection of the best communication position is consistent with the fit total function. Each rule has its own importance. We use set of the weight to show its priority of the rules.